In this lecture, we'll talk a little bit about networking. Networking is a central feature of Internet of Things. We'll talk about why it's needed, how it's helpful. Also, we'll start talking about general structure of networks, sort of the broad categories of networks. Why is networking needed? Well, it enhances devices. It makes things better, let's say. So it enhances features by giving you access to computational complexity outside of the local device. So if the Internet of Things device is a camera or a phone or a car or whatever it is, the fact that it's connected on a larger network means that from that smaller device you can access much more powerful servers, much more powerful, much bigger databases. You can access all that through whatever the device is. And having access to all this computational power and all this data can be used, be leveraged to enhance a lot of devices and improve their features. So for instance, cars, say a car, it's an Internet of Things device, they can communicate with each other on a network to improve traffic flow. So wouldn't that be great if cars were all talking on a network and they could plan their own routes and consider the fact that other cars were planning their own routes? They could collaborate together to make the flow fast, right? Which, by the way, is possible and probably will happen in a decade or so. But it takes a while to get those things worked out. But that's probably going to happen. There's no reason why that can't happen, and that would be very useful. So it's an example where you're enhancing the feature of a car by using the networking. So they can now talk to each other. They can talk to a centralized database and get mapping information and things like this. Online gameplay, we all know about that. Or I do. So there are a lot of games. In fact, there's a large segment of games where you can't, there isn't much to play by yourself. You have to play online, right? Call of Duty, for example, or Destiny, or whatever. Those games, you play them online, and it opens up a whole new world to you, literally, right? Many new worlds. You can connect to different people and do all sorts of extra things that you couldn't do locally on one machine. Accessing media libraries, Netflix, for instance, right? Or Amazon Instant Play, or whatever library you're using, you can only access those. Sure, maybe you're using a TV as your Internet of Things device, but it alone doesn't have the library of all movies ever created, right? You have to connect through the network to Netflix database or whoever it is. So networking is useful. It's very useful. It enhances abilities of any particular device. Now, the communication between an Internet of Things device and the main network is usually, most commonly, follows a client-server model that we're showing here. So the client would be the Internet of Things device, right? And that's a smaller machine, relatively less powerful machine, connected to some server. And you see that in the middle. The server, it is guarding and protecting some resource, giving access, let's say, to a resource. So you see the resource over there on the side. The resource can be any kind of resource. Maybe it's a web server, and and the data for the web pages is in that resource or something like that. And then the server gives access to that resource. So the client, which might be the Internet of Things device, that thing is communicating, making requests of the server to get whatever the appropriate information is. The server then manages the resource. So it handles the request, gets whatever it is that is needed from the resource, and sends it back in the form of a response to the client, which would be your Internet of Things device. And maybe you see the web page, or you have whatever data you were looking for, or you get the movie that you wanted to look for, something like that. So this sort of client-server model is very common. The client is generally less powerful. That is, it's a smaller machine, literally less power, it's slower, where the server can be a very large cloud-based server, very powerful, plugged directly into the wall, has lots of power, cooling fans, whatever it has. So, and the resource can be whatever you want, a bank of disk drives and some machines, whatever you want. So this is typically the model that you see Internet of Things devices communicating with the network through. So we're going to talk about three really broad classes of networks right now. First, LAN, Local Area Network, stands for. And a local area network is just a relatively small network. It usually spans building, a campus. A campus might have this one local area network, a floor of your building. You've had experience with local area networks, I'm sure. Now, typically, the way you access these networks is either through a wall socket, an Ethernet jack in the wall. See one right here. Also, Wi-Fi routers. I see one in here too, right? So we're familiar with those. Local area network is commonly for a building or something relatively small. Okay. Now, on the other side of that, there is a wide area network, the other extreme. Wide area network, the best example of that is the internet itself. That's an extremely wide area network. And a wide area network is just a lot more complex than a local area network. There's a hierarchy of machines that are communicating together. So it's really, a wide area network is really a different class of network than a local area network, has different protocols involved. And internet is basically the wide area network that we'll be talking about. Now, in addition to this, we have mobile ad hoc networks, MANETs. These are actually important to Internet of Things components because mobile ad hoc networks they're composed of largely mobile devices, thus the term mobile. And a lot of Internet of Things devices are mobile. And it's an ad hoc network because it reconfigures itself constantly. So that is maybe an Internet of Things device, a cell phone, let's say, comes into range of the network, then it joins the network. But you continue walking, and you walk another block, and you're outside of the network, right? So the network is reconfiguring every few seconds. Maybe something is walking into the network, something's moving out of the network. It's very dynamic. So that's what a MANET is. And a lot of Internet of Things devices are part of a network like that, of a MANET. And you need different protocols for that. You have to assume assume that things are mobile, so power is a constraint, right? Because you're usually battery driven if you're mobile. So they have a different class of algorithms for MANETs as well. Thank you.